Hi, my name is Leo, and this is my student number 216542237. Here's my student card. Right. Now, today I'm going to talk about the programming assignment for my data structure and algorithm class. So basically, this is about the making lexicon list for the word. So in the first task, I'm going to do the represent the class word and all the method I'm going to use for my programming. Here is initial class method that we have spelling for the words, frequency for how many times that word is happens, and the neighbor word list. This one will contain that the word is considered as a neighbor when it have the same length and only different each other by only one letter. This one is function for raising frequency for the depth for the word that similar exist in lexicon. Increase one. This one is checking that if the word is the lexicon, like I said, if that word is the same length, not same length, false. If that word is exactly the same, false. We don't count that one. And we check that all the word and look through all the letter. If they are same letter, if have different letter, we will increase the count. And if the count is larger than one, it's return false, because it's only accept as the neighbor word if that word is only different by one word, not two, not more than one or not less than one. This one you tell class how we compare two objects, because we only can compare two word string integer in Python, not the two objects. So we have the function to tell the code that how to compare two objects. This one is to define the return type that we can read, make the return type in the readable way. We can read the data when we call the lexicon. We can hear spelling, frequencies, and neighbor. That's because this is all the object. If we not define this one, we cannot read that. It's only return this address of the object. So we have this one to define it, to make it become the readable string, actual data about it. Okay, moving into the task 2, I have constructing a lexicon here. I'm creating the lexicon list, make the read data word by word, remove all. It will receive uh, one line of the data in each loop and remove all these white space, separate all the words on that line into the words list here, and from then it remove all the punctuation and numeric character. When all this finished, it will lowercase all the remaining letter. That's and that is where we receive the two words, which we call lexicon. And here we have checked that if that word is still exists on lexicon, we will increase that frequency, the number it exists on there. Or if that word not exists on the lexicon, we will add it in the lexicon list. Okay. Finally, we append. We call the data, call the function, read data to receive the data to lexicon. That's all. So after this, we have the lexicon list. Okay, but it's not sorted. So we move to task 3, where we use the algorithm to solve it. In here, in the first algorithm, I will use the quick solve, because this one is, I think, is gonna be the most fastest one. So we have two parameter here: lexicon left and right, left border and right border. We will set the right gonna be the length of lexicon -1. That's obviously to make sure that it's not go far more than that. Left and right, this one is for the recursion. Make sure that it's not do it infinitely. It has a constraint when the left, we can consider the left pointer is smaller than right. And we have to find the pivot index to do the, let's use the quick sort. So here, basically we find the we're gonna find the uh, pivot by divide the last method to the first method by 2. We take the middle, consider as a pivot, and swap it to the end. When we have that, we will use two pointer. If the pointer is still left and right, and the value of that word is in that array is smaller than the pivot one, we will continue to raise the pointer in the left, continue to go to the right, and if it's larger than the right, we will swap the position, swap the value of the left pointer to the right pointer. This one, in order to find the greater element and the greater to the left, to the right, and the smaller value to the right. Same like here in, and after that, we will, the left and the right pointer will meet each other in the middle, and we return that is our pivot. Continue recursion here. Yeah. And the second one, I'm gonna use the hybrid method between the merge and the selection. The merge here, still use the recursion from here, same like that, but we use the concept divide and conquer here. Every element go through. If one element is smaller than another element, we will swap it. This only in the merge. We will check that. We will compare two sub-array that, and we will find that if the element from the left array or the right array is smaller than another array, we will put the element into the merge array first. Do it again, and until one array is finished, we will copy the rest of the left. The the one array is not all the value in that one. We will put that all in the merge. So we have the merge, and we'll do it recursion again and again, and we will got the final list. But that is a divine conqueror, and in here we gonna use combine between them and use insertion sort. We will only use, because the insertion sort is efficient in the smaller array, smaller list. We do not to divide all the subarray till the very last element. So we have the constraint here, which we will call the threshold. I will leave it in 16 when it defines a large array data and do the 16 array, 16 up array, 16 up sub array, 16 up array. It will use the insertion sort to find the value. That's gonna be faster than if we continue to divide and merge it together. We solve it when it's reached 16 element in the array. We solve it and merge it together. Write it down. Okay, so move to here. We have the time profiling, and I will reduce this one to check the timeline, the real time, the hybrid sort take and the quick sort take. Here. Okay. So the first time, I think is the quick shot take a lot of more time than the real the quick shot. No, the quick shot is much more faster than the hybrid shot. You can see here. Let's try it again. Same results. The quick shot it's faster than the hybrid results. So here. Okay, we move to task form, where I will create the interface for the user to choose which sort they want. In here, for example, I want the quick sort. I will choose number 1. So we use the quick sort function here, and we call that quick sort function. If I want to hybrid one, I will choose number 2. It will use the number 2 hybrid sort. Okay, we move to task 5, where we gonna finish what we left, that is the neighboring words. So It's not so hard. We just make one pointer loop all over the lexicon and other pointer all over the lexicon to check this one to find to go forward, find all the rest of the lexicon except this first one. If that another word that's considered as the neighbor of this one, of this word, and we will use the function we already the method we already defined in the first class here. It's gonna be this one. Yeah, it's condition. Yeah, and if that return true, we will put that in the neighbor art neighbor. We will put it in the neighbor list, and we will use a hybrid list here to sort that hybrid here right over here. Okay, and after that we call the function and we finish this one. Pretty easy, right? Okay, so this is gonna be the final form where we're gonna be writing lexicon to the file. Nothing so much. Just define the function, the word file, and we just make the new file and make the name that gonna be our text, and we put our final lexicon in here, run it, and I open it, and it's gonna be like this. Huh? Hold on. So here. Oh, I think I have to run back this one. I'll forget to run this one. Okay. And exalt. Oh, sorry, forget to run this one. Okay. And here, boom. Yeah, that's all. And you can see that's or here. That's the this one is a word, this one the frequency of bits, and this one the neighbor word bits. Yeah, here old neighbor of R and as AT. Yeah. So basically that's all about my programming assignment. Thank you for listening.